Right, good morning. So, as it says on the slide, my name's Alison Hagger, and I'm here today to tell you about an adventure that we've been on at the IET for some time now. I joined the IET's Knowledge Division towards the back end of 2012, and I had a brief to look at new ways of presenting knowledge to both our current customers and to potential new customers. The team had already done quite a bit of research, so we therefore already knew what we thought our users wanted, which were, as I guess you all know, detailed answers to specific questions rather than links to lists of documents containing more documents that might or might not contain the information that they require. And they wanted, obviously, to achieve this using an interface that had as near Google simplicity as possible. But on the plus side, we also had quite a lot of content. We've got over 14 million records in InSpec alone. So, our next question was not that. I'm just trying to wander around in this screen and having difficulty. Have you any idea how I can actually... No, I just wanted to stay in the notes bit. Sorry about this, small technical difficulty. So we can go back up the page. But how do we get into that panel?
Just go back for a second.
Sorry guys, we'll be done in just a sec.
Can you get it now?
Okay. Yeah. Will that just let me... Yeah, it's just... Okay. Yeah, I don't need to see the slide. That's better.
Oh, okay.
Right. Okay, so the next question was how we married these two things together without creating just another website. So we very quickly, therefore, focused in on natural language processing and semantic enrichment technologies. Now, the ultimate goal, of course, was to answer questions across the whole field of engineering and technology. But I felt that this breadth of scope was partly the reason that was hampering progress to date. We needed to focus in on a small area of engineering. We needed to build something, play with some real data, answer some specific questions, and then work out how to scale this up to a wider audience. So we reduced the scope to renewable energy, and we focused on content providers who were geographically close to us, so we could actually work with them face to face. And we also selected 4 representative user types, 2 of them academic researchers and product development engineers who we already know quite a lot about. And we also looked at what we could provide to product managers and consultants who we don't work with so closely currently. And we then carried out a series of in-depth interviews with representatives of these users to find out what information they needed to support them in their roles and which bits they currently found particularly difficult to source. And this research was used to spec up a prototype with some very, very specific goals. The first of those was being to actually test out the reality behind the hype of semantic enrichment and the sort of practical uses of natural language processing. And secondly, we wanted to investigate data storage, building an API, how we could build a reusable front end, because we needed to assess production costs for a real system. Loads of people have done research in this area or small projects, but there's very little that's actually out there on the market really using semantic enrichment. And thirdly, we wanted to investigate what mix of content we'd need to answer these questions we'd unearthed. Did we actually have that content, or were we going to have to go outside and source it? And if that was the case, what was it going to cost us? And last, but certainly not least, how best we could make the products and services we uncovered during the prototyping process available to our end users. So this is a screenshot of the prototype that we actually built. Specifically, it shows a UI that allows people to select the market vertical they work in and the job role that they actually do. And once selected, these criteria have they have two functions. One is actually to interpret the search results, and the other is to help provide answers to specific questions. And the specific questions we focused in on answering were things like, who's carrying out research into technology X and related subjects? Is research into a particular technology and related fields increasing or decreasing? What companies specialize in a particular technology near a particular location? What companies near a location specifically operate, develop, manufacture, or install a specific technology? And as we were looking at renewable energy in particular here, is a specific location suitable for installing a specific type of renewable technology? And linked to that, could you show me information, contextual information, about people who've already installed and are operating that type of renewable technology in areas close to me? And in addition to answering these questions, we also created profiles for all the people and the entities that we extracted during the enrichment process. That was about 1 million people and 100,000 organisations. So I'm going to show you some screenshots of the prototype a bit later, but first I'd just like to return to some of the underlying work that we had to do in order to be able to answer these questions. So, as I've already said, the very first thing we needed to do was to look at our data. Did we have the information we needed within InSpec to answer these questions that we decided to try and answer? And was it held in the right format to make this possible? And the honest answer to both of those questions is no. So the first thing we actually had to do was create a data model. This is a very simple example of a data model on this slide. Now, we had a bit of a head start because we already own an engineering and technology taxonomy, the InSpec Thesaurus, which contains around 20,000 terms which have been manually compiled by subject matter experts over the last 40 years. But we also knew that if we wanted to do something really interesting with the prototype, we needed to make a much more broader model of concepts and relationships, which included people, organizations, places, activities, products, publications. And just to give you an idea of how powerful this way of arranging data is, this simple structure on this slide would allow a system to answer a question like, can you give me the names and email addresses of people working for organizations who develop wind turbines? An example perhaps closer to home, because I know we've got a number of publishers in the room, would be if we added publications, because then we could answer questions like, who are the top contributors in the field of wind turbine motor research between 2012 and 2013? Or is wind turbine motor research a growth area in 2013? If we then add patent data into the mix, we can start to answer even more complex questions like, wind turbine research was identified as a growth area in 2010. How many patents have been filed since then? In other words, we can use our engineering domain model to assess how quickly academic research trends lead to product innovation. So let's go back to the prototype and see some of the questions and answers in context. So, as this slide says, we reduced those questions into 3 apps with those names: Research Trends, a Renewables Directory, and something called Generate Your Own Power. And we used these to explore different aspects, both of our data and of the engineering data model that we'd created. So this slide shows how we answered the first question on our list: who is carrying out research into technology X and related fields? Because of the entities we chose to model and the relationships that we made between them, we were able to rank authors both in terms of the number of publications that they'd made over time, as well as by the number of citations of those articles. In addition, we used the GeoNames API to enable us to plot the location of authors based on the address of the organisation they were most recently affiliated to. Now, I know that doesn't always work, and we heard that in our last presentation, but that was what we decided to do here for the purposes of prototyping. And we also pulled in tweets based on the search term, as well as creating profiles for the people and the organisations we identified. So this is a profile of a person. that we created. So in this case, we provided this gentleman's email address so you could contact him. We identified those areas that he specialises in, and we provided links to individuals associated with the organisation that he's most recently associated with. And also, which you can't see there, if you can even see that much, we provided a list of organisations that he'd been associated with over time, to give you an idea of where he'd worked. On the second tab, we did things a little more traditionally. We've provided links, list of all the abstracts that he's published over time, and we produced a little individual tag cloud, which you can see a corner of. On the third tab, we linked to patent abstracts where he was identified as one of the authors. Because of the way that we've stored the data, every time a person or an organisation is mentioned, you can click on that name and you can go through to a profile. We'd hope to extend that to mentions of other things in a full-blown system, but this was a big enough challenge for us in our prototype. We'd also like to extend a person's profile to include social media and news, but actually disambiguating people is really hard work. And it's especially hard, for example, to link a person to their Twitter handle, which may have no link to them at all in any other respect. Profiles of organisations were actually a little bit easier to put together, so we have a little bit more detail. Just in the contact details, you can see we found out more. We can even find logos in some cases, and we used DBpedia to find descriptions of the organisations that we found. We also looked at listing similar organisations based on groups of tags, and we also included third-party data sets by linking to things like Open Corporates for their API for company and financial data, and to a number of sources for patent data. We used the American open source patent data that's been published quite recently, but also the European Patent Office API, which covers Europe and the Far East. The main learning points for us while we were doing this was, while it's possible to create profiles automatically using semantic enrichment and scraping tools, first of all, based on purely scholarly publishing data, you get so far, but not really far enough to make this interesting. So you need to include other data sources. But what you also need to do is manually complete and curate this information. The automated tools available on their own don't give you enough to make this reliable and complete. So moving on, the second question we wanted to answer was, is research into technology X and related fields increasing or decreasing? So as you can see on the slide, we provided this for individual technical concepts, so all the 20,000 terms contained in InSpec, and also other terms we discovered during the process. And once again, we produced a list of publication abstracts with links to the full text and to all the profiles for the organisations and people that we'd identified. Now, because we'd also decided to focus in on renewable energy, our next application was more obviously focused in this area. It was built to answer two questions: what companies specialise in technology X near location Y, and what companies near location Y operate, develop, manufacture or install technology X. Now, the IET already has a directory product called ENT Marketplace, which is compiled in a very, much more traditional manner. So we were keen to explore what could be done with a combination of web scraping and semantic enrichment techniques to reduce production costs and add additional functionality. And as you might expect, the results were mixed. We found identifying relevant companies was easy, but extracting product information was hard. Company websites do not follow any rules, so sadly, maybe we could have some standards for those as well, but I think that's going to be a long time coming. So we were able to pull out interesting and relevant filters, however. So we customized our filters linked to keywords that we pulled out as being statistically relevant in that area. And we found we could incorporate social media and news feeds quite easily based on the company names and the other information that we had about the companies. But again, we needed manual curation for this, and there's an aspect of updating that's very important if you're going to do this profiling. However, you pull it off automatically, but you've got to keep pulling it off and keep updating it. I think a metric that's used widely is this stuff, about 25% of your data will be out of date within 12 months. So you've got quite a big task behind that. And this was the third application that we built to answer the last two questions in my original list. And we developed this in conjunction with a UK trade association, Renewable UK, who specialises in wind energy technology. And this app is actually an interactive version of a PDF brochure that they currently publish on their website. So once again, we incorporated a number of third-party data sets, many of them disparately produced by the UK government. For example, the UK is mapped on kilometre squares for wind speeds at 3 different heights. So that was great. The main difficulty with that was actually not getting the data, but finding the column headings, which for some reason the UK government published separately in another file on another website. I don't know why. I think it must be an old hangover from some military security thing. I have no idea. But we got there in the end. And the idea here was to give users a much more interactive experience. They could search by postcode. So, you're a school and you want to put a wind turbine up on your school. So you stick your postcode in. You can see quite clearly from the overlaid grid whether or not there's any chance of you having enough wind over the year to produce anything usable. If you do, what we wanted to do is, instead of saying, well, it's a good idea to go off and get a wind gauge, don't go to a company, they'll charge you lots of money, we put a button in, and using that app that I showed you on the previous slide, we located a number of people that could supply you with a wind gauge in your area, and you could just hire one. It would arrive in the post. You could stick it up in your backyard. If that worked, and the period to do that is apparently 3 months, you could then go through and we'd link you to installers, again, in your area, who could then come round and do a full-blown survey and help you through the planning process, etc. We also used more open data sets to create a searchable database of all current installations, because again, in the UK, you can actually find output statistics for everybody that has a wind turbine operating. And we provided contact details and statistics about whether they'd actually generated the amount of power that that size of turbine should produce and that kind of thing. And it also, because we'd done all the profiling, we could put people in contact with each other, particularly to talk about planning advice, which I believe is a very fraught business. So that's the prototype. And once we'd done that, we held a number of workshops with everybody that had been involved, all the organisations and third parties that were involved in this, particularly those who'd provided content to us. And our initial aim for these workshops was to review the prototype and gauge their interest in creating a production version, which seemed pretty straightforward. But what we found when we talked to them was that actually what they were really interested in was using this technology to tell them about their own data and the world in which they operate. So this has led us to look at a number of additional services that we could make available, things we'd already invested in. So we started looking at things like trained semantic enrichment modules, because you can buy this stuff, you can go to a number of organisations and they'll give you the software, but if you don't have a taxonomy to train it against and you don't have a lot of manually curated data, it does nothing. The old rubbish in, rubbish out, unfortunately. So we've looked at that. We've also looked at providing this in a hosted way, because a lot of people, a lot of publishers we've talked to, don't have data held in the format that you need to hold it in to actually get these advantages. But you don't need to do that, because we've already worked that out, and you can take data and we could enrich it for you. And again, if you really, really don't want to know about semantic enrichment, but you want to benefit from it, why should you have to know? You don't know how your car works, but you drive it. So with the experience that we've had in indexing and QAing, etc., we're very happy to work with people to look at how we can expose what they're interested in from their data. And this is just a sort of a quick list of the things that we thought specifically to the publishers in the room might be really interesting. Because we believe that these services, with sort of this unique combination of automated enrichment, manual QA, and editorial services, allow publishers to improve things like content acquisition strategy, growing and maintaining peer review networks, things like keeping authors up to date. Every time an author is referenced in something, why are we not just sending them a text and telling them? And why we're not pulling together a list of researchers working in a particular community and suggesting to them that they might like to cite the articles from our journals. So a few final thoughts. At the IET, we're actually really, really excited about what's possible when you mix semantic enrichment and a domain model for engineering with our existing QA and indexing services. And the work we've done on the prototype suggests that this framework, applied to a breadth of content types and sources, really can create truly linked data, which will make a huge difference to end users. And those end users might be academic researchers, but they could also be product managers, practicing engineers, consultants, a whole raft of people, in fact anyone who works in engineering and technology who has a question that needs answering. So my final message to all of you is, if you've got engineering data and you'd like to discover more about it and what it could tell you, either in isolation or in conjunction with the wider in-spec engineering universe, then please get in touch with me or with David here or Daniel Smith, who some of you may know as well. And thank you for listening.